The perception of the world as solid and real, despite everything being composed of atoms and particles of energy, is a result of complex interactions between the fundamental constituents of matter and the way our sensory perception and brain process information. This phenomenon can be explained by several factors: scale and relative size. At the macroscopic level, the distance between atoms is so small compared to our everyday experiences that we don't notice the gaps. The forces between atoms and molecules create a sense of cohesion, giving objects their apparent solidity. Electromagnetic forces. Electromagnetic forces between atoms are responsible for the sensation of touch. When we touch an object, it's the repulsion between the negatively charged electron clouds around atoms that gives us the feeling of resistance or solidity. Sensory perception. Our senses are designed to perceive the macroscopic world. Our sense of touch, for instance, responds to the collective forces exerted by countless atoms and molecules, creating the sensation of physical contact and solidity. Brain processing. Our brain processes the sensory inputs it receives and constructs a coherent representation of reality. This construction doesn't necessarily mirror the true nature of atoms and particles, but provides a functional representation that allows us to navigate and interact with our environment. Perceptual illusions. Our perception is influenced by various cognitive biases and perceptual illusions that make us see and experience things differently than they truly are. These illusions can reinforce our sense of a solid reality. Consistency with experience. The world appears solid because this perception aligns with our consistent experiences. Objects don't typically pass through one another, and forces like gravity and resistance give us a sense of interacting with solid entities. Quantum effects. Averaged out. At the macroscopic level, the probabilistic and quantum behaviors of individual particles get averaged out, leading to the classical behavior of matter. Quantum effects like tunneling and wave-particle duality, which are more pronounced at the atomic and subatomic scales, don't significantly impact our everyday experiences. Evolutionary advantage. Evolutionary pressures have favored the development of senses that help us survive and navigate in the macroscopic world. Our senses prioritize detecting immediate physical threats and opportunities rather than focusing on the underlying atomic and subatomic structure. In essence, the perceived solidity and reality of the world around us emerge from a combination of sensory perception, brain processing, the properties of matter at larger scales, and our evolutionary history. While everything is indeed made up of atoms and particles of energy, our everyday experiences and interactions are shaped by the way our senses and brains interpret these fundamental building blocks of reality.